Have you ever pondered why the largest planet in our solar system, Jupiter, has a lower density than Earth? It's a question that's puzzled scientists and space enthusiasts alike. Jupiter, a gas giant and the fifth planet from the Sun, is over 11 times the diameter of Earth and over 300 times its mass. Yet despite its colossal size, it has a significantly lower density than our home planet. Jupiter's composition plays a key role in this density dilemma. Unlike the rocky planets, like Earth, Jupiter is primarily made up of hydrogen and helium, similar to the Sun. These elements, while abundant, are much less dense than the iron, oxygen, silicon, and magnesium that make up most of Earth's mass. To understand the density of a planet, we need to consider both its mass and volume. Despite its massive size, Jupiter's voluminous gaseous composition results in a lower average density. So the question remains, why does Jupiter, with its massive size, have such a low density compared to our much smaller Earth? To understand Jupiter's density dilemma, consider its formation and the materials it comprises. The story of Jupiter, like all planets, begins in the vast cosmic cloud of the solar nebula. It's a tale of elements and compounds, temperature and distance from the Sun. In the outer regions of the solar nebula, far from the Sun's intense heat, temperatures plummeted. This allowed a variety of elements and compounds to condense and clump together. These weren't just the heavy rock and metal elements that formed the inner planets. No, here, in the frigid outskirts, lightweight volatile compounds like water, methane and ammonia could also survive, condense, and contribute to planet formation. This is where our gas giants, including Jupiter, began their cosmic journey. As these elements and compounds coalesced, they formed a solid core. But this was just the beginning. The core's gravitational pull attracted even more of these volatile compounds, creating a thick atmosphere around it, and so Jupiter, the largest planet in our solar system, was born. But here's where the density dilemma comes into play. Despite its massive size, Jupiter has a lower density than Earth. You see, density is mass divided by volume, and while Jupiter's mass is substantial, its volume is colossal due to its thick gaseous atmosphere. The elements and compounds that make up Jupiter, such as hydrogen and helium, are far lighter than the rock and metal that dominate Earth's composition. So even though Jupiter is over 1,000 times the volume of Earth, its mass is only 317 times that of Earth. That's why, despite its size, Jupiter's density is only about a quarter of Earth's. It's like comparing a basketball to a bowling ball. The basketball is larger, yes, but the bowling ball is denser because it's made of heavier material. Thus, it's not just about size but what you're made of that determines density. So we've learned that Jupiter's lower density is due to its composition and formation process. This mighty gas giant, with its swirling storms and impressive size, isn't as dense as it might appear. Distance from the Sun, temperature and composition all play a crucial role in determining a planet's density. In Jupiter's case, its location in our solar system, far from the Sun's heat, allowed lighter elements like hydrogen and helium to stick around, resulting in a less dense planet. Understanding Jupiter's density dilemma doesn't just shed light on this one planet though. It offers us broader insights into how planets form, and even provides clues that can help us discover exoplanets, those elusive worlds orbiting stars outside our solar system. In the grand cosmic scheme, Jupiter's density dilemma reminds us that even the mightiest planet is subject to the fundamental laws of physics and chemistry. So the next time you gaze at the night sky, remember there's more to a planet than meets the eye.